Everyone, welcome back to day 2 of probability events. So today we're going to talk more about how to figure out probabilities. We're going to learn about independent and dependent events. And we're going to just continue to explore what probability is. So we're going to start with an exploration. Remember, whenever I put up a problem that I'd like you to try, pause the video, try it out, and then we'll discuss. We'll see what the answers are. Okay, so you've unpaused the video. Let's look at this problem. Mr. Minowitz's marble jar has 12 green marbles and 8 violet marbles. A marble is randomly selected and replaced. So we take one, we look at it, we put it back. A second marble is selected. What's the probability that the second marble is green? Well, in this case, if I put the marble back, I still have the 20 marbles, I still have the 12 green and the 8. So really, the second trial is the same as the first trial. I can pick 12 out of the 20 are green, and I could simplify the fraction to 3/5. Okay, this is called with replacement. Now the second situation is a little bit different. A marble is randomly selected and not replaced. And now, from the 19 remaining, we have a second marble that's selected. What's the probability that the second marble is green? Well, now we have two different things that could occur. And it really depends on, was the first marble green or is the first marble violet? So to pick a green second, if the red or violet is first, we still have 12 greens in the bag, but we only have 19 total now. But let's say we pick a green one out first. We still have 19 marbles in the bag, but now only 11 are green. So this second example is going to be considered a dependent probability, where the second pick depends on what we already took out of the bag, because the odds, the probability has changed. The experiment's changed. Down here, the first pick was out of 20 marbles, and then the second pick was out of 19 marbles. If we replace it, we're going back to independent trials where the second one is not affected by the first pick. And the definition of independent events are independent if a trial is not affected by what we previously did, and it's dependent if there is an effect. So if the probabilities change based on doing something previous, those two events are dependent. So generally, when you're doing replacement, if you replace the item and pick again, that's independent. But if you take something out or you change how it's working, let's say I can't pick that first green marble again, then it's dependent. And we have some formulas related to that. So here's an example. If I roll a die and toss a coin, neither has a memory of the other. If I roll a 1, that doesn't tell me whether I flipped a heads or a tails. Okay, so these probabilities are independent. So if I want to roll a 4 and to flip a heads, I could just multiply the probabilities to see what's the probability of them both happening, because neither affects the other. So the probability of rolling a 4 is 1/6. The probability of flipping heads is 1/2. The probability of rolling and flipping and getting both 4 and heads is 1/12. And if you're not sure if we can multiply, we write the sample space out. So we can have a 1 heads and a 2 heads, all the way up to 6 heads. And we could have a 1 tails and a 2 tails, all the way up to 6 tails. And we're going to have 12. And the only one we said we wanted was 4 with heads. So there'll be 12 events, and one of them is the one we want, the 4 and the heads. But if they're independent, we could just take each probability and multiply. But here's an example. Once again, I'd recommend you pause the video, you read the problem, you try it out, and then you can see my explanation when you unpause the video. Okay, so now we're going to have to deal with Alex and not being able to decide which shirt to wear today. So she chooses one at random. Now, we also know that the probability of rain is 40%. 40% as a fraction is 2/5. So now what's the probability that she chooses a yellow shirt and we don't have rain? Now, I don't know about you, but I don't pick my shirt based on the weather outside. So I'm going to consider those independent. Okay, and I'm going to write down the probabilities that I have. So I know the probability of rain is 0.4. We could also do 2/5, but I like decimals. Probability of not rain, so the complement is 0.6. And remember, they got to add up to 1. Then I'm going to look at yellow shirt. So I see 2 yellow shirts out of 4. And if you're having trouble with colors, I am too. But I think I would consider 2 out of 4 to be yellow. And then we want to know if they're independent, which I think they are because I don't think color of shirt affects whether it's raining or not. So what we can do to figure out the probability of picking a yellow shirt and not raining is we can multiply. So we take the probability of the yellow shirt, we take the probability of not raining, we multiply them, and we get a 30% chance that Alex chose a yellow shirt and it's not raining today because they're independent. So here's another example. Okay, but this is a little bit more complicated, so make sure you try this out. You think about how this question differs from part A, and unpause the video when you're ready for the answer. Okay, so we're dealing with the same 40% that it's going to rain, 50% yellow shirts. So we can write those down, rain, yellow shirts. But the second part also says, what's the probability that Alex chooses a green shirt and it rains today? So now we have 2 different situations. We're going to find the probabilities from each one of them, and we're going to add them together. So they're independent still, picking a shirt color and rain, not affected by each other, so we can use the multiplication rule. Now, we already did the top one, the probability of yellow and it raining. We multiply and get 30%. Now, we also want choosing a green shirt and it raining. This 1/4 of the shirts are green, so 25%. Raining, we already said 40%. And now we can say these events can't happen together. So we talked about mutual exclusivity in day 1. So now we can just add the probability of yellow and raining with the probability of green and raining. So there's a 30% chance that one happens, a 10% chance that the other, and it's a 40% chance, or 0.4, that either or happens. Okay, we find each individual probability, and since they can't overlap, we can just add the probabilities together. Now here's a more challenging example. Once again, try it out. Okay, now that you've unpaused the video, we spin the spinner 2 times. Okay, blue is 1/3 of the circle, orange is 2/3 of the circle. What's the probability of getting the same color both times? So we have 2 different situations that we could have here. Okay, first I like to write my probabilities. I always love writing down information, making a table of data. Okay, the spinner is independent. If I spin an orange once, it doesn't mean that I can't spin orange the second time or that blue's any more likely. The spinner is going to stay the same. So I like to mark it down that I have independent events. And now I have one case where it says probability of getting the same color both times. So I can spin and get orange the first time and orange the second time. And since they're independent, I can multiply the probabilities to get 4/9. But it doesn't say which color I need. So I could also have blue and blue. And the probability of blue and blue is 1/3 each time, and you multiply them together and get 1/9. So now the probability of orange and orange, or blue and blue, we add them and we get 5/9. So if events are independent, we multiply the probability of each event happening together. If two events can't happen at the same time, that's called mutually exclusive. So we can't have two orange spins and two blue spins at the same time. That's crazy. We can add them together, the union, and that's how we solve this problem. So this is compound probability. Lots of probabilities where we got to think about, do we multiply, do we add, and what are we trying to calculate? So in summary, mutually exclusive are when two events can't happen at the same time. Okay, if I flip a coin, I cannot get both heads and tails. Okay, it doesn't work. And independent events are when two events happen one right after the other, and the first event doesn't affect the other. So if I flip a coin and then I roll a die, neither event changes the outcome of the other event. And here are some formulas that you can use. Okay, so mutually exclusive example and independent example. And that is probability events.